Hey class, so we are going to be talking about lesson 2.7, polynomial and rational inequalities. And our first example here asks us to solve and graph the solution set on a real number line. And we're given the polynomial 2x squared plus x is greater than 15. So we're going to walk through this step by step. And our first step asks us to express it so that it is greater than 0. So let's write that down. So for step 1, we're going to express in the form f of x is greater than 0. Okay, and you might be wondering, well, why did I pick greater than? Well, all you have to do is look back at the original inequality, and that'll tell you what your inequality sign should be. So if this had been a less than sign, this would also be a less than sign. So that's where that's coming from. Okay, well, how can we make this look like some function greater than 0? What can we do? Well, you're absolutely right. We can just subtract that 15 over. So let's go ahead and do that. I'm going to subtract 15 from both sides. And that leaves me with 2x squared plus x minus 15 is greater than 0. So that is our step 1. Okay, are we ready for step 2? Step 2 asks us to pretend, just for step 2 anyway, that instead of saying greater than 0, this said equals 0. And solve for x. Okay, so we're going to set this equal to 0, this polynomial that we have, and solve for x. So I'm going to do that now. I'm going to turn my page. So I've got 2x squared plus x minus 15 equals 0. And I'm solving for x. Okay, so I've got this quadratic situation going on. Any ideas out there of how I could solve for x? Yes, I could use the quadratic formula, you're right. Or I could turn to my good friend who has never led me astray, Xbox. So let's set up our Xbox. First, in our big X, we put negative 30 in the top and 1 down here. All right, can anyone out there think of any factors that multiply to negative 30 and add to 1? Absolutely. 6 and negative 5. Okay, so we fill in our box. We've got 2x squared in this window, negative 15 down here, and then we put in our 6x and our negative 5x. So as we find those GCFs, we fill out the outside. So the greatest common factor of 2x squared and 6x is 2x. And the greatest common factor between negative 5x and negative 15 is, you got it, negative 5. And between 2x squared and negative 5x, that's right, just x. And between 6x and negative 15, absolutely 3. So now we have 2x minus 5 times x plus 3 equals 0, and we want to solve for x. So we know now x is negative 3, or x is 5/2. And we call these our boundary points. Our boundary points. Okay, and those are going to come in handy in step 3. Okay. Are we ready for step 3? Great, so I'm going to turn my page again. So for step 3, let's pick a new color. We are asked to locate the boundary points. Locate the boundary points on a number line. Okay, so let's draw ourselves a nice number line. I know I need to get to -3 and 5 halves, so 5 halves is really 2.5. So I'll go out to -3 here, here's 0, here's +3. Okay, so if I plot my boundary points, quick question, are these going to be open circles or closed circles? Yeah, you're right, they're going to be open, because if you remember, looking back at our original inequality, it was just greater than. It wasn't greater than or equal to. So these are going to be open circles at -3 for that boundary point, and at 2.5, which I'm going to say is like right here. Okay, we're not quite done. Now we need to figure out where are we going to shade. Are we going to shade in between here? Are we going to shade on the outsides? Where are we going to shade? How do we figure that out? Well, that's where step 4 comes into play. So in step 4, we're going to choose one test value within each interval. And you might be wondering right now, what do I mean by interval? By interval, what I mean is, let's see here if I can get some different colors. So interval would be from -3 down to -infinity. That's one interval. Okay, another interval would be this middle piece here from -3 to 5 halves. That's another interval. And the last interval we need to look at is here from 3 up to +infinity. So within each of those intervals, I need to pick a test value and plug it into my polynomial. So for example, okay, from this interval here, -3 down to -infinity, I'm going to go ahead and test -4. Okay. From this interval between -3 and 5 halves, I can pick any number in between there. I'm going to pick 0 because 0 is going to be the easiest one to test. And last but not least, from 3 up to +infinity, I can pick, from 5 halves up to +infinity, I can pick any value, 5 halves or bigger than actually, not 5 halves, because remember 5 halves is not included here, to test. So I will test 3. Okay, what do I mean by test? I mean substitute it into the polynomial and see what you get. So for -4, that would be 2 times -4 squared minus 4 minus 15. For 0, that would be 2 times 0 squared plus 0 minus 15. And for 3, that would be 2 times 3 squared, that's 2, times 3 squared plus 3 minus 15. Okay. And what we're looking for here is we're looking for the signs of our answers. We want to know, are they going to be positive or negative? So I would love some help now. Can you tell me what you get when you plug in -4? That's right, you get 13, and 13 is, by the way, positive. So I'm going to mark it with a plus sign off to the side to remind myself that it's positive. Okay, when you plug in 0, you get absolutely -15. Okay, that's negative, so I'm going to mark it with a negative. And when you plug in 3, that's right, you get a +6, so that is a positive. Okay, so I need to think back to my inequality now. I think back to my inequality and I ask myself, was I looking for greater than 0, meaning positive numbers, or was I looking for less than 0, meaning negative numbers? Yeah, you're right, we were looking for greater than 0. So we want the test values that resulted in positive numbers. So which ones were those? Absolutely, they were -4, that resulted in a positive value, 13, and 3, that resulted in a positive value of 6. Okay, so what does that actually mean if I'm choosing those numbers? That means I'm going to shade where those numbers fall. So -4 falls in this region out here, so this is where I'm going to shade. Okay, there we go, it's a little better. And where does 3 fall? Well, 3 falls in this region out here, so that's where I'm going to shade. Okay, this is a terrible shading. And I'm almost done. Step 5 is just to write this in interval notation. Can we write our solution in interval notation? So I'm going to go ahead and turn my page. On my page, I'm just going to really quickly redraw what our number line ended up as, so we can refer to that as we are writing our interval notation. Okay, so let me pick a new color. So we had a boundary point at -3, a boundary point at 5/2, and we ended up shading this way and that way. So I would love some help just writing this solution in interval notation. And this would be our step 5, by the way. You write, oops, sorry about that. Let me fix that. Okay, so step 5, write solution in interval notation. Okay, there we go. So an interval notation. Okay, how can we represent this interval over here? That's right, it starts at -infinity and it goes up to -3. So is that going to be a parentheses or a bracket? You got it, it's a parentheses. We're going to union, and then we're going to start up at our next boundary point over here. That's 5/2, and that goes all the way up to, that's right, positive infinity. And this is our final answer, and that was my example 1. Why don't you guys go ahead and try checkpoint 1 in your book to make sure you are understanding this, and click on the next video for example 2.
Made with Doodlecast Pro.